All right, so you all probably thought you were going to get lucky and not have to have notes today, but sorry. We are still going to take notes just as normal. So today we are going to talk about how to graph a function rule. So the last couple of days we have been talking about how to write a function rule. So I just want to remind you that what a function rule does is it might say something like y equals 3x plus 4. And what that will do is it can generate a bunch of ordered pairs. So I might say, okay, if I were to plug in 0, 3 times 0 is 0, and 0 plus 4 would give me 4. So when I plug in 0, I get out 4. Well, then I could turn around and I could plug in 1. Well, 3 times 1 plus 4 would be 3 times 1, which is 3. 3 plus 4 would be 7. And I could keep going, and I could generate all sorts of numbers here. So keep in mind that if I could generate all sorts of numbers, it means that although I plugged in 0 and I plugged in 1, I technically could plug in 1/2 or 1/3 or 1/4. I could really plug in anything that I want for x. So if I'm talking about me wanting to list all of the solutions, it's just not possible. Kind of like whenever we were talking about inequalities, and kind of like with inequalities, how we said, okay, I can't list all the possible solutions for an inequality. This is why we like to graph inequalities. So this is why we like to graph a function rule, because I can't list out all of the solutions for a function, so we're going to graph them. So if I want to talk about the set of all of the solutions for an equation, that is going to form the equation's graph. Okay, the graph is the visual representation of all of the equation's solutions. Now here's the thing. What we're going to do today is we're going to generate a handful of solutions for each equation. But like I said, although I found the answers for when x is 0 and when x is 1, there's actually a ton of solutions in between those two numbers, but we're not going to find them. So keep in mind that a graph may include solutions that do not appear in a table. So we're not going to find all of them, we're just going to find a few of them. Okay. Now we are also going to talk about real-world graphs. Now real-world graphs, and we'll talk about this at the bottom, they should only show points that make sense in the given scenario. So we'll talk about that at the bottom. So to graph a function rule, we're going to follow kind of similar steps for every single one of these. The first thing we're going to do is we're going to make a table of values. After we make a table of values, we're going to graph all of those ordered pairs. Then we're going to connect the points if it makes sense in the given scenario. And then whenever we connect them, that's how we're going to graph the points. So in a way, this is actually doing the opposite of what we did yesterday and the day before. Because yesterday we were given a table, or we were given a whole bunch of points, and I was trying to come up with the function rule. Today we're given the function rule, y equals negative 2x plus 1. I'm going to list out a bunch of numbers. I'm going to find a bunch of solutions. Now, for linear functions, which if you notice, y equals negative 2x plus 1, if you remember, this is going to be a linear function. I already know that, kind of making connections here. I know that because it's in the form y equals something x plus something. So we're already expecting this to be a line. With our functions, okay, we are going to choose what we plug in here for x, because you can technically plug anything you want in for x. You could plug in 100 if you wanted to. But here's the thing. We're going to have to graph these numbers here on this graph here. So if I plug in 100, I'm going to have to go to the right to 100, which is not even on that graph, and then figure out what y I get for that. So that's not really reasonable. So we want to make sure that our points fit on the graph if possible. So we want to use these x values here. So we want to use, for this specific graph, I probably want to plug anything from -5 to +5, looking at those x values, because remember, this is your x-axis. Now, although it may be simpler and easier to just plug in positive numbers, sometimes it's not going to give me a good enough picture of what my function looks like. So we do want to plug in positive and negative numbers, but we also do want to make our job as easy as possible. So here's what I would suggest. most of the time it's going to be reasonable to plug in -2, -1, 0, 1, and I know I'm short a little, I know I'm short a row there, but let's go ahead another row so we can add in 2, because these are the numbers we're going to plug in for your homework assignment. Now, the reason why I want to plug in these numbers is I can see some numbers on the left side, some numbers on the negative side. I can see some solutions on the positive side, but they're pretty small numbers, pretty easy to work with. Now, what we're going to do is we are going to take these numbers and we are going to plug them in for x. So for the first one, I'm going to plug -2 in for x. So my function rule says we're going to take -2 times, okay, well, x we said is -2, and then my function rule says we're also going to add 1. Well, -2 times -2 is 4. 4 plus 1 gives me 5. And then we're going to do the same thing with -1, except this time we're going to take -2 times -1 and then add 1. Well, -2 times -1 is 2. 2 plus 1 is 3. And we'll plug in 0, -2 times 0. My computer will let me work here. Hold on a second. -2 times 0 plus 1. -2 times 0 is 0. 0 plus 1 is 1. And then we'll plug in 1. -2 times 1 plus 1. -2 times 1 is -2. -2 plus 1 is -1. And finally, we'll plug in 2. -2 times 2 plus 1. -2 times 2 is -4. -4 plus 1 is -3. Now, what I've done here is I have generated 5 solutions. I've generated 5 ordered pairs. Even if they're not written as ordered pairs, these would be the points -2, 5. I'm getting that by taking this x and pairing it with this y. I have the point -1, 3, just doing the same thing. I have the points 0, 1, 1, -1, and then I have 2, -3. What I'm going to do is I'm going to take all 5 of these points and I'm going to put them on my graph. So I first have -2, 5. So we're going to go left 2, and we're going to go up 5, and we're going to put our point right there. I'm then going to plot -1, 3. So we're going to go left 1 and up 3. We're going to put a point. 0, 1, we're going to stay right on that y-axis and just go up 1 and put a point. Okay, we're going to plot a point at 1, -1. So right 1, down 1, and then 2, -3 would be right 2, down 3. Now, remember what I've done is I've calculated 5 solutions. These are not the only 5 solutions. There are a ton more solutions. I could have plugged in -3. I could have plugged in 3. I could have plugged in -0.5, right? I didn't, but I could have. There are other solutions on this graph that I didn't put in the table. So what I've done right now is I haven't graphed the function. I have just graphed 5 solutions of the function. If I want to graph the whole function, I would need to connect my dots, and as I was expecting, it forms a line because it is a linear function. That's the main idea of what we're doing today. Now, I'd mentioned up here that on step 3 it says connect the points if it makes sense in the given scenario. When we're talking about real-world scenarios, sometimes it may not make sense to connect the points. So we have what's called a continuous graph and we have what's called a discrete graph. So once again, we're just talking about real-world scenarios here. So a continuous graph is going to be a graph that's unbroken. So it would make sense if you could plug in not whole numbers for x. So in this case, my x coordinate is gas. So since I have connected this graph down here, it means that I could buy any amount of gas that is shown on this graph, meaning I don't have to buy just 1 gallon of gas or 2 gallons of gas or 3 gallons of gas. If I needed to, I could buy 4.5 gallons of gas, or I could buy 5.25 gallons of gas. You don't have to buy exact integer amounts, gallons of gas. Where if you look over here on this discrete graph, a discrete graph is going to be represented with distinct, isolated points. So the example here is if you're buying t-shirts, because here's the thing, you can only buy one t-shirt, or two t-shirts, or three t-shirts, or four t-shirts, or so on. If you were to connect this, it means that you're trying to tell me that I could buy 2.5 t-shirts for $30 or whatever that may end up being, which is not true, right? You can't buy half of a t-shirt. So this is what would be called a discrete graph. Okay, that's all we're going to do on that section. I'm going to have you guys hold off for just a second to get that glued in. You'll glue it in right at the end. We're going to move right into our examples. So the first thing we're going to do is exactly what we did on that first example. We are going to complete a table of values, and then we're going to graph the functions. We're going to do 4 of these. Okay, so number 1, our first function rule says y equals 3x minus 4. Okay, so the first thing that we want to do here is we want to complete a table of values. So this is going to look like just like what we did on that left-hand side. So we're going to need a column for our x's. It's kind of nice to have a column for our work. If you like, you can put your function rule in that middle column, if that helps. So y equals 3x minus 4. And then in that last column, here's what you're going to see on your homework. That last column is actually going to pull those two things together and pull it into that ordered pair that we are then going to turn around and graph. Okay, now remember, on our graph, because we're going to want to graph all of these, we want to be able, ideally, to fit this line on my graph. So I don't want to plug in these totally crazy x values like 50 for x, because I don't want to count all the way out to 50, and then I don't want to count up to whatever that y value would be. But we do want to include some positive and negative numbers. So you're going to do the same thing when you get to your homework. I want you to plug in -2 and -1. We'll plug in 0, 1, and 2. So we're keeping it consistent. We're going in order. Notice we have negative numbers, we have positive numbers, but they're kind of the easiest options to work with. And then you're just going to plug these numbers in. So my rule this time, we're going to plug these numbers in for x. So we're going to take 3 times the first one. We're going to plug in -2 minus 4. So 3 times -2 is -6. -6 minus 4 is -10. We're actually going to tie both of those together, so we have our ordered pair, -2, -10. Then we're going to plug in -1. So this time we're going to take 3 times -1 minus 4. 3 times -1 is -3. -3 minus 4 is -7. So that ordered pair, when I plug in -1, I get out -7. When I plug in 0, we're going to find out that 0 is usually pretty easy to work with. We're going to take 3 times 0 minus 4. 3 times 0 is 0. 0 minus 4 is -4. So when you plug in 0, you get out -4. Okay, whenever I plug in 1, we're going to take 3 times 1 minus 4. 3 times 1 is 3. 3 minus 4 is -1. So we get a point 1, -1. And then when we plug in 2, we're going to take 3 times 2 minus 4. So 3 times 2 is 6. 6 minus 4 is 2. So we get the point 2, 2. So it does not have to be a perfect graph, but we do need to sketch these out. Notice that my y values do go all the way down to -10. And we're going to go 2 to the left, 2 to the right. Go all the way down to -10. And they're going to go up to 2. And then we're going to go ahead and throw all of these points here on my graph. So we're going to start with -2, -10. We have -1, -7. We have 0, -4. We have 1, -1. And we have 2, 2. Now, it does not have to be perfect, but if you noticed, it is a line. Now keep in mind, like we said, although I plugged in -2, -1, 0, 1, and 2, there are other solutions here. There's a ton of numbers in between 0 and 1 that I could plug in. We definitely don't want to, but there are solutions in between those 2 points, so we need to make sure we connect our line to show that. Okay, we'll come back to that. Let's do number 2. Okay, number 2, this one's going to be a little different. It says y equals the absolute value of x plus 2. Let me redo that. Y is absolute value of x plus 2. Now, first thing, we want to set up our table of values. Now, I'm going to tell you that you're going to do basically the same thing that you're going to do on your homework. So we're going to have a column for our x's, a column for our work, and then a column where we pull together our x and our y. Keep in mind that we are going to want to graph all of these points. So like I've been saying, we don't want to plug in these totally crazy numbers, but we want negative numbers and positive numbers. So probably -2, -1, 0, 1, and 2. Now be really careful here because when you're plugging numbers in, we are plugging them in here for x. So if we look at what the function rule is telling me to do, we're going to take the absolute value of x. So we're going to talk about its distance from 0. Then we are going to add 2. So first I'm going to take the absolute value of -2. Then I'm going to add 2. So first when I'm taking the absolute value of -2, -2 is 2 steps away from 0. So I'm going to take 2 plus 2, which would give me 4. So when you plug in -2, you get out 4. We're going to do the same thing with -1. So we're going to take the absolute value of -1 plus 2. The absolute value of -1 is 1. 1 plus 2 is 3. So we'd get a solution of -1 comma 3. When I plug in 0, we're going to take the absolute value of 0 plus 2. Absolute value of 0 is 0. 0 plus 2 just gives you 2, so you'd get the point 0 comma 2. Now, when I take the absolute value of 1, remember absolute value is distance from 0. If I'm talking about 1, 1 is 1 step away from 0. So you take 1 plus 2 and you get 1 comma 3. And then finally, I take the absolute value of 2 plus 2. Just like I said before, the absolute value of 2 is 2. 2 plus 2 is 4. So we get the point 2 comma 4. All right, and then we want to go ahead and throw these on our graph over here. So we're going to have 2 to the left, 2 to the right. It looks like my y's go up to 4. So my first point is -2 comma 4. I have -1 comma 3. I have 0 comma 2, 1 comma 3, and 2 comma 4. Now, just like before, remember, although I didn't plug in 1/2, I could plug in 1/2. Although I didn't plug in -1 and 1/3, I could have plugged in -1 and 1/3. But if you look at this graph, it's not one straight line. It's a line that comes down and then it actually gets kicked back up here. So the absolute value graph is going to look like that. Okay, let's do one more that we are graphing. Let's do, okay, number 3. Let's do y equals x squared minus 3. Okay, so just like before, we're going to want our table of values. We've got our x's. Our rule is y equals x squared minus 3. And then our last column will be those x comma y's that we get. And then we're going to graph our function. Okay, just like before, we want negative numbers, so -2 and -1, and we want positive numbers, 1 and 2, so those are going to be the easiest ones to plug in. Now for this one, you need to be really, really careful, because if I look at my function rule, what it tells me to do is I'm going to take x and I'm going to square it. So when I plug in -2, I am going to take -2, the whole thing, negative included, and I'm going to square it. Then I'm going to subtract 2. Now when you take -2 squared, that includes the negative. That's going to be -2 times -2. Negative times negative is a positive. So that's going to be +4 minus 3, which is 1. So you get -2 comma 1. Same thing is going to happen when you plug in -1. You're going to take -1, the whole thing, even the negative, you're going to square it, and you're going to subtract 3. So -1 squared, -1 times -1 is a +1. 1 minus 3 is -2. So we get -1 comma -2. Okay, 0 is lovely to work with. We would take 0 squared minus 3. 0 squared is 0. 0 minus 3 is -3. So we would get 0 comma -3. When I plug in 1, we would take 1 squared minus 3. 1 squared is 1. 1 minus 3 is -2. So we would get this point 1 comma -2. And when I plug in 2, we would take 2 squared minus 3. 2 squared is 4. 4 minus 3 is 1. So you would get this point 2 comma 1. Now this time, when we put these on our graph, it's going to look kind of like the absolute value function. So I get negative 2 comma 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and then 2 comma 1. Now at first glance it may look just like the absolute value function, but the absolute value function formed straight lines on the left and on the right, and if you were to do this really accurately on graph paper, you would notice that these are not straight lines, that this one actually ends up being a curve. A quadratic function is going to end up being a curve. Okay, now the last thing you're going to do is this idea of talking about continuous versus discrete. And you'll have a few of these to do on your homework. So what we want to do is for each scenario, we want to decide whether the graph would be continuous or if it would be discrete. And then we're going to sketch an example of what the graph might look like. So number 5, it says the amount of dog food needed to feed a dog depends on the weight of the dog. So it might be easier to kind of start thinking about what your graph might look like. So what this is going to be is you're going to say, okay, well, depending on the weight of the dog, okay, that's going to tell you how much food that dog is going to need. And in general, this may not be what our graph is going to look like, but in general, I would assume that the more the dog weighs, the more food they're going to need. What we need to decide is that if my graph is going to look like this, or if it's going to look like this. So the difference is, it would mean that if I can have a dog, do I have to have a dog that weighs 1 pound, or weighs exactly 2 pounds, or weighs exactly 20 pounds? Or can I have a dog that weighs 35.5 pounds? Hopefully your answer is yes, that you don't have to have a dog, right? Most dogs don't weigh an exact whole number measurement. So this is going to be a continuous graph. So a graph that's connected is going to be a continuous graph. Okay, now this other one is talking about something that I'm going to be doing this coming weekend. Not myself, but my brother-in-law, talking about a wedding. So this is talking about the cost of meals for a wedding depends on the number of guests that attend the wedding. So once again, we're going to draw kind of our little graph here, and along the bottom, what we're changing is, okay, here's how many guests are going to be here, and up this side is going to be the cost. And once again, it might help to just say, okay, in general, the more guests, the cost is going to be more. But in this one, notice, I can't have 25.5 guests at my wedding, or 35 1/3 guests. I either have to have 1 guest, or 2 guests, or 10 guests, or 20 guests, or 200 guests, or 300 guests, whatever it would be. This one is going to be a discrete graph.